Now, when I told you that we have a linear model when one quantity changes at a constant rate as another quantity changes, you may have immediately thought of proportions. What is a proportion again? A proportion is a statement that two ratios are equal. More specifically, two quantities are proportional if their ratio is constant. Okay, what does that mean in practice? I'll give you an example. If one works for an hourly wage, one's pay is proportional to hours worked. So that means the ratio of pay to hours worked is constant. It doesn't change. How do we use that? Suppose we have someone specific in mind, say Jim, and he makes $70 if he works for 8 hours. We'd like to write an equation relating the hours that he works and the pay that he earns. Well, the ratio, we're going to write it in fraction form, of his hours worked to his pay is constant. So the ratio of H to P is the same as it is in this first story we heard. It's 8 hours over $70. Right, notice the way we set up this ratio. Hours, hours, pay, pay. Now wait, you say. That doesn't look like a linear equation. See here, we are dividing by a variable. But think back. How do we go about solving a proportion? If only one of these were unknown, how would we go about solving? Well, to solve a proportion, we look at these two guys, right? The cross products. Those have to be equal. So H times 70 must equal P times 8. Or to write this in a more normal way, 70H equals 8P. Now this, right, we only have H, it's multiplied by a constant, and P, it's multiplied by a constant. This equation is linear. So proportional relationships often give us linear equations. I'm going to give you one of these to try. Suppose I tell you that an object's gravitational potential energy, whatever that is proportional to its height above the ground. Suppose a certain bowling ball has 100 joules of gravitational potential energy when it's 2 meters off the ground. Write a linear equation relating U, the object's gravitational potential energy, in J joules. H, its height above the ground, in M meters. These notes about the units just tell you that you don't need to worry about them because we're not bothering with any unit conversions here. So, just using the fact that these quantities are proportional, pause the video and try writing this linear equation now. Okay, well, gravitational potential energy and height are proportional. So U over H is constant. In particular, U over H equals this specific energy over this specific height. Again, this is not a linear equation because we're dividing by the variable. But now we cross multiply. U times 2, that's 2U. H times 100, that's 100H. This is our linear equation. Now, some of you may have written this proportion with heights in the numerators and energies in the denominators. That would give you the same linear equation, wouldn't it? So it doesn't actually matter which you choose as long as you're putting the same thing in the numerators, the same thing in the denominators.